Hello everyone. I want to go over the requirements for assignment number 5. Assignment number 5 is really the second part of a two-part assignment. Assignment number 4 begins our foray into data warehousing. And assignment number 5 is really the culmination of that, but you cannot complete assignment number 5 without first doing assignment number 4. Okay, let's go into the requirements for assignment number 5. So expanding upon the high volume Home Office Supply Company's data tracking requirements, the Chief Financial Officer, that is the CFO, requests your services again to extend the data model's functionality. The CFO has read about the capabilities of data warehousing analytics and business intelligence, that is BI, and is looking to develop a smaller data mart as a test platform. And that's in fact what happens. Before businesses, particularly smaller businesses, invest money in a data warehouse and the corresponding data analytics that go along with the data warehouse, which can be a substantial investment. What they'll do is use a test platform, a smaller data mart, which really is a small data warehouse. Just as an FYI, you can have both at the same time. So you can have a small data mart inside of a data warehouse as well, or even multiple data marts. But generally, data mart is considered a small data warehouse and many times used for testing. He's under pressure from members of the company's board of directors who want to review more detailed sales reports based upon the following measurements. Sometimes they'll call these metrics. That is product, customer, sales representative, time, and time we're going to normalize into or I should say normalize is not the best word, but time we're going to break that down into year, quarter, month, week, day, and time. That is hours, minutes, and seconds is the last attribute here. And then location. Now location we will normalize. So further, the board members want location to be expanded to include the following characteristics of location, and that is in region, state, city, and store. Here are the deliverables. Again, gang, please make sure that you are doing this this is Microsoft SQL Server, which can be accessed through the labs.cci.fsu.edu. Here are the requirements, essentially similar to assignment number 4. However, you're going to have 25 unique records in the sale table rather than before, and then at least 5 unique records in all other tables. So 25 records in the sale table, and of course, don't forget, as per assignment number 4, we need 15 records in the person table. So 15 records in the person table. Either break that out into 5 and 10. Customer can have 5, sales rep can have 10, or vice versa. And really, you want to test your data with a substantial amount of records. You guys, that's the only way you can really test how your data model, how your design has been developed, is by including a decent amount of data inside of your either data warehouse, data mart, or just your regular database. So 25 unique records in the sale table. Okay, I'll go into the differences between A4 and A5, and then also we're going to go into the SQL statements, the store procedures. Excuse me, in another video. All right, but again, please make sure that you have your design in SQL Server. The other thing is, gang, I've been showing you this ERD using my MySQL Workbench. However, no credit will be given for the assignments as far as the ERD goes, unless this ERD is designed in Microsoft SQL Server, which, if I have a chance here, I did show that in class. But if I have a chance here in the videos, I'll do the same thing again. But again, you can create the ERD if you'd like, and I encourage you to do so. But to get the credit for the assignment, you must do it inside of SQL Server. And the reason why I want you to do that, so you get experience of creating ERDs inside of SQL Server. All right, let's begin. Now, the first thing I want to say first thing I want to say is we have most of these entities already. We have product, we have customer, we have sales rep. We don't have time broken down. We don't have location broken down. Let me show you the distinction between assignment number 4 and assignment number 5. As you can see here in the top left corner, this is the ERD for assignment number 4. And as I scroll down, you could see this is the ERD for assignment number 5. Very similar. The difference here is in how we break down, how we actually creating this data mart for sale. Sale really here is the fact table. Now, when you're reading through your textbook, please make sure that you understand the distinction between the various schemas, what a fact table is, what a dimension table is, what a star schema is versus a snowflake schema, and also make sure you understand why we have these distinctions, and what the purpose of the different types of schemas are, as well as what the differences in the dimension table versus a fact table. All right, let's begin. Now, there is a difference, and I want to focus on, I want to focus on that difference in the store table, okay, the store table. So, you'll notice here in assignment number 4, we have store ID, name, street, city, state, zip, like we did before, okay? But in assignment number 5, we have an additional attribute called city ID. Now, what we're doing here is we're breaking down we're actually normalizing the location. And that is so that we can garner we can break down the additional dimensions of location into region, for instance, north, east, south, and west, state, of course, we're just dealing with the United States right now, but we could break that down in a global database, data warehouse as well. So, we're breaking it down to 4 different regions, northeast, south, and west. 5 actually, central too. Central. So 5, northeast, south, west, and central. And you could do it any way you wanted to. You could break it down into 4, just northeast, south, west. You could do it that way as well. And then we have state, city, and then the foreign key of city goes into the store table. So that's our first difference here. Also, I want you to understand that the sale data mart contains both the star and snowflake schemas. Now, in your textbook, the snowflake schema involves the normalization of another dimension table. So again, what we're normalizing here is a location table, or if you, as per the book, a location dimension. And that location dimension is actually broken down into region, state, city, and store, with the city ID being a foreign key. Notice how the dimension tables and the snowflake schema have a relationship. So region is the parent table to state, which is the parent table to city, which is the parent table to store. Additionally, we have a timetable. Now, this timetable is broken down. Notice, again, our 3 rules of database design. Number 1, all tables must have a primary key, and a primary key cannot be null. Number 1 rule, by the way, is entity integrity. Number 2 rule is referential integrity, and that is the foreign key must match the primary key in the parent table. And again, region is parent to state, which is parent to city, which is parent to store. So if you have, say, in the region table, the primary key is tiny and unsigned, then the region ID in the state table must be tiny and unsigned. So it must be tiny and unsigned, apart from the fact that it must agree in the values. So here if we have the values for a region, which would be northeast, southwest, and central, 1 through 5. The only values that we can have for region ID and state would be 1 through 5, and it must be tiny int, and it must be unsigned. All right, time. We're breaking that down to year, quarter as a tiny int, month as a char 3, meaning January, JAN, February, FEB, March, MAR, etc. So char 3. Time week is going to be a tiny int. That would be 0 through 6. Day is going to be a tiny int. I'm sorry. Week is going to be... I have to look at my data on that. I believe our week is going to be 1 through 52. We'll look at the data together here in another video. I forgot what I put as, I've been working with quite a bit of data here, and I forgot if I put week as 1 through 52 or 0 through 51. I may have had it as 1 through 52. And day is either 0 through 6 or 1 through 7. Not sure about that. We'll look at the data together. And time is going to be a date time. So in other words, it has hours, minutes, seconds. The date time, I kept it as a date time because we're also going to include here, we could have the year, if necessary, to break that down. So the date time can be, in fact, a date meaning year, month, day, hours, minutes, and seconds. And then any notes about that time. Our sale. Now, the sale, gang, is going to be our fact table. And I want to show a couple differences here. It depends upon the version of MySQL Workbench that you have in this particular design. Again, you're going to have to create your ERD using SQL Server, not MySQL Workbench. I highly encourage you to do that for your online portfolio, but what's required for the assignment is actually to have the ERD in SQL Server. Now notice how by the way, a fact table is made up of, contains the foreign keys of its respective dimension tables. So the dimension table here for sale, one of them is product. You see product ID is a primary key in the product table, but it's a foreign key in the sale table. Store has its own primary key, store ID, but it's the foreign key in the sale table. CNT for contact. Contact ID is a dimension table for the sale fact table, and contact ID is the foreign key in the sale table. Time ID is a foreign key from the time ID table, which is a primary key. Then it has its own additional attributes. Sale quantity, sale price, sale total, sale notes, which we'll get into another video. I indicate here too that the sale is the fact table. Okay? And that the sale data mart contains both star and snowflake schemas. So the star schema involves product, contact, and time. The snowflake aspect of this design involves the normalization of location into store, city, state, and region. All right. Now, again, notice the difference here between store and A5 and A4. A4 does not have the city ID as a foreign key in the store table. So that's the first modification you have to make, is make a city ID here. But before you do that, you want to make a region table, a state table, a city table, a store table with these attributes right here. And then, of course, each child table contains the foreign key of its parent table. So state will have the foreign key of the primary key in region. Likewise, city will have the foreign key of state ID in the parent table of state, and store will have the city ID foreign key from the city ID primary key in the city parent table. And sale, these all 1, 2, 3, 4, your fact table contains foreign keys. Now, notice it looks like a regular key. Well, if you open up, now again, I know Mac users, it looks differently, but if you open up on a PC, it will, on a new version, so this is an older version than I have of this design, same design, nothing's changed, but the foreign keys that make up also that are primary keys, in other words, they have the dual functionality of being a PF, a primary key, and a foreign key, look magenta in the newer version on a Windows machine. On the older version, it was just gold. So it looks like a regular primary key, so you really couldn't tell that they are actually foreign keys. But in the newer version of MySQL Workbench, you could see that it is a key, and it's different from the look of the foreign keys in other tables that have foreign keys because it also is not only magenta, but it is a key icon as well too. So the whole point about having a fact table is that the primary key, as we have not done before, only a few times, and I try to avoid them, but in the data warehousing you cannot avoid it because that's part of the design. The primary key in a fact table is made up of a composite number of keys from all its respective dimension tables. Okay, so the primary key in the sale table is made up of contains the primary keys as foreign keys in the same table. The primary keys are from their corresponding dimension tables. A product ID in the product table, contact ID in the contact table, store ID in the store table, and time ID from the time table. All right, gang, that's the design, and we'll go into the T-SQL that you'll be doing here to create your tables and populate your tables. See you in another video.